is TELUE and welcome to CEB101 Lecture 6 for Steel Structures Drawing for Introduction to Structural Engineering Drawings Steel Part 1. Okay, so here we will look at the different types of block symbols that you can have inside of your AutoCAD template so that you can be able to use that each time you do your steel structural drawing. Usually we should already have a template for your title block and your layers created, and then create your block symbols inside of this template and use them as your template for steel structures. So today I will just tell you how to draw a simple universal beam. Okay, so here in our lecture today we will talk about the different types of steel sections that you have. If you look at table that is shown now, table 4.2 of your Australian standards for structural drawings, you'll see that table 4.2 on the chapter 4, page 16 of the Australian Engineering Handbook for Structural Drawings, you'll see that you have different steel sections. Okay, so as you can see popping up on our screen now, you'll have the universal beam, universal columns, rolled channel, rolled angle, flat bar, flat plate, and round bar or rod. Okay, these ones are square bars, your circular hollow sections. All of these are your normal types of universal beams that you can have. So in our case, we'll take our dimensions from our one steel tables. Which, okay, the next table also that you need to know for your Australian standards, your structural drawings, is make sure that you have table 4.1 open for applications of lines. Okay, you can see that popping up on the screen now, where you have continuous extra thick lines, single line, diagrammatic marking plans and elevations. You have your continuous thick lines for visible outlines of steel elements. That's A. Designating letter A. B. Your continuous thin lines which are for cross hatching of steel sections, dimension lines and leaders, diagonals across holes or recesses, and welding symbols. In our case, for TELUE Engineering Limited, we use layer 0 as our dimensioning lines and cross hatching and all of that. When we create your layers, we have that for our case. Okay, C for continuous thin lines, where we have break lines around large areas, break lines in individual elements as sections. And D, we have hidden outlines of your steel elements, which is dashed medium. Your designated letter for your application of line for E is chain thin, which you can use for central lines, centroidal lines, and grid lines. In our case, we can create layers using these different types of application of lines, and then we can also use these for when we want to print or plot it, using different plot styles for different colors to give us these lines when we are printing them. Okay, so thing that you also need to do. Okay, but that is for another video where I will show you how to create layers for structural engineering drawings introduction. Okay, next table is the table for 4.3, as you can see popping up now on the screen. That is for welds and the different types of welds that are used for welding purposes. So we have type of weld fillet, appearance of the weld, and the weld symbols that can be used. So that's shown there. Okay, we have our square butt welds, our single V butt welds, double V butt welds, and single bevel butt with backing run, and single bevel butt with fillet on the side. Okay, that is table 4.3. That is if you're doing structural engineering connections, detailing, and you have them having welds. These are the symbols that you will use on the table 4.3. Okay, our next one that we can, okay, those are the tables now that you can use for connection detailing, for drawing a simple bolt section connection details. I will show you in a later video on how to do connection details. Okay, thank you all for listening and moving. Okay, the thing that you need to know about structural drawings is that you have to have a template, a title block of the drawing that you are going to draw for your different steel structural drawings. Your template of your steel drawings should have your title block, should also have your steel sections already inside of it, so that it could be easier for extracting, or you can have another it already created as a template on a separate drawing and then insert it into your drawing to make it easier for you to draw the drawing. Okay, next thing, you should also have different sections. So in our case, if you want to draw different sections, you should use the dimensions given in the one steel book that I use to teach my students for, and then already draw your steel sections so that it and create a template of it, and that can be kept to be used through any steel drawings depending on the size of the beam or column or square section or circular holder section that you will be using to design your drawing. Okay, design your structure or your building or your warehouse. Okay, for our case now, the case that I will be showing you is that normally in a structural drawing you will have a schedule that is provided in your general notes and drawing index, which is the very first page of your structural engineering drawings, or you can have it on a separate page where you have your general notes given, where you have your steel form work, your concrete work, the live loads and dead loads that are going to be used in the design of the building. It should have your concrete work, your steel work, everything inside of it. So you can see now coming up on the screen an example of a general notes. Okay, in our case we kept our drawing index also inside of this, where it gives you the drawing number and sheet inside. Okay, can you see that coming up on the screen now? That's that one. Okay, so these are the normal parts of a structural drawing. You can see that you have your general notes and drawing index, which is the one that I've shown coming up on the screen now. The next one is your footing slab plan that you should have, your block walls and mezzanine floor steel layout and details, and also the next one is your steel truss and section and typical details, and steel roof plan and details. Okay, so we'll be using that all throughout as the basis of our lesson. Okay, but this is just an example. It depends on the type of structural drawing that you're drawing and the type of building that you will be building, but normally you should have this type. This is for a real project that we did. I will not reveal what project we did, but just to give you an idea of what you would find in your general notes and your drawing index. Okay, in this lecture, like I said again, is to show you guys how we would draw a drawing in AutoCAD and already have the templates available for us to do our drawing. Okay, thank you, and we'll move on to the lecture. Okay, today we're going to go through CEB101 lecture for structural engineering drawings. So the first thing that we need to do, we have to have our books open to one steel hot rolled sections, because we're going to use an example through a universal beam column, so that we can create block symbols, and then on a later video I will go through how to create from this particular universal beam drawing. We can create templates for it to use in other structural engineering drawings. Our next thing that we'll do is we'll also look at our different symbols for drawing practice that you use, which we've already gone through in our other videos, and I will go through it again. Not really necessarily in this video, but for a later video. And then we'll also go through our different plans, but as an example, we'll use one of our drawings for one of the projects we did in our company. Okay, our next thing, okay, not this one. Okay, next thing we'll do now is we'll open AutoCAD. Okay, first thing that you do, you open AutoCAD and you can use it to create the drawings. So in my case, I use AutoCAD 2010. Okay, so we'll go through now and we'll draw our universal beam. So because we're trying to create a template for a universal beam or columns that we'll use inside of any engineering drawing, we need to have one steel or any manual that you'll use to draw, depending on the type of steel material that you use. If it's hot rolled products, then use one steel. If it's cold form, you use another manual, depending on the type of manufacturer that does your steel products. Okay, so in our case, in our example today, we'll look at this one here. We'll draw 250 UB 37.3. Okay, as one of the structural elements. Usually you'll use it, this cross section, for your floor plan where you have your column. You can also use it in your column details, connections, and all of this. Okay, so to make your life easier, it's good to have a template for these types of materials so that you can use it for every time you want to create a structural drawing, so you do not need to draw it again. Okay, so I'll begin by that. First, I'll just take a snapshot of the dimensions so that I don't have to keep coming back to this page all throughout my lecture. So I'll just take a snapshot from my PDF and then we just paste it inside of our AutoCAD drawing. Okay, so it's already there. Okay, so I have 37 UP, 47. So we also take another snapshot that I should take, help me identify the sides. Just take a snapshot, wait. Take a snapshot, ready. In here. Take a snapshot, place it here so I know how it looks. Okay, next thing now, we'll just zoom in to get our values. So I'll go up here and then I'll just use line command. Okay, so first depth of our beam is section is 256. So we go 256. Enter, and then my BF, the width of my flange is 146. So we go down again. Hey, my drawing. So we offset 146. Then we go, what's that? BF minus TW. So BF minus TW. So in our case, it's 146 minus 8.2. So I'll just take my calculator first. 146 minus 8.2, and I have my value as 137.8. Okay, and then I divide that by 2, giving me 68.9. Okay, so offset again, 68.9. Okay, just check the dimensions for our web. 8.2. Okay, next thing we need to do is take the thickness of our flange. So thickness of our flange is 10.9. Okay, using line command again. .9. And then we use trim to trim all the edges that don't necessarily need to be in our trim. Okay, our universe beam is still not okay yet. We have to chamfer our corners. Okay, so we have this one here, our radius R1. R1 value in for our case for 250 37.3 is 8.9. Okay, so 8.9, just go down here. 8.9, we use home, go to home, and we go to chamfer and fillet. In our case, we'll use fillet. Okay, so because we're trying to create a curve. Okay, so fillet, select first object, this one, second object. Okay. Fillet, it says select first object or radius, so we type radius, and then we use our radius, which is 8.9, and then we select our first object, second object. Okay, we do that for our second one also. Fillet. Okay, the radius was already 8.9. If you're trying to do it for another universal beam, then you'd have to change the radius, so you'll have to repeat the first step again. But for our case, it's for the same one, so we don't have to repeat the first step again. We just go on and select our first object. And there we have our universal beam. Okay, so now it looks something like this. Huh? Okay, next thing we do now, because we're trying to create a block object. Okay, so to create our block object now, we have to choose the command to complete. So we'll have to go to this one. Now let's make block object. This one. Okay, it's this one. Okay. Okay, we'll just go type block. Name the block, so we'll say 250 UP 37. Specify object on screen. Yeah, we can use, if you already have a layer that you're listed in our case we haven't created layers yet, that will be for another video. Layers, line type, line scale, plot style, and all of these properties which you want to have the same. So we'll just say layers, and probably more line weight. Okay, line weight. Okay, and then we say okay. Why I selected line weight, or we can say plot style by plot style. Okay, because most of our drawings, when we want to print it out, we use plot style. So we say okay. Then we select Okay, let me go on screen, specify on screen. Okay, okay, and then we have our block editor. Okay, in this one now we'll have to create, because in some cases you use a flip section and all of this, so where we can flip it, so I'll rotate it. Okay, so I'll use rotation. So we select our parameters first to rotate before you can. So specify base. So our base would be somewhere in between here. If we want to rotate, specify radius. Just take specify angle. Okay, 180. Then we go to rotate and we have the action here. And we select the object. So everything that we want to rotate. And press enter. Okay, and that should give us our um, rotation parameter for our objects. Okay, so I already selected, right? Selected the object just to make sure. Okay, then I okay, just remove this one. Okay, then this one. Okay, so now we have it, and then we just save this one. I think we have to close the block editor. Close. And you say save changes for drawing. You say yes, and then you say oh, okay. I think it's okay. Close. Move it home. Mm, close. Okay. Save the changes you made to 250 AB set 87. Okay, now we'll look at how we can rotate. Okay, so it's becoming one object, and then we see if we can rotate, and we can also rotate it. Okay, so there you have it. If you do not place this parameter to rotate it, it won't be able to rotate and all this. So now we have our block symbol to, so if you want to insert it each time, you just say insert and it will insert into your system. So you can also save this whole drawing as a template. So we say save as AutoCAD template. Let's have a problem with this. Just go retrieve it first. Retrieve it, open coloring, drawing, backup files. Okay. Okay, after you've drawn a drawing now, you will have to save it as a template. You can draw all of your universal beams, so you can have it all in one, and then you can use it. You can do the same for your universal columns, and also create the template for universal columns, your title block, your AutoCAD, everything, title block with the title block with the layers, with the plot style, and also with your universal beams, universal column. And from there now you can use it every time you draw a structural drawing. Okay, so we save. And just save it in my documents first. Okay, as lecture 6.1 structural engineering drawings. Okay, in our next part we'll talk about creating already having your layers and whatever created, and then having them all inside. Okay, or we could say block drawings structurally. Part 1, block reference universal beams. Okay, save. Did I save it as template? Save. Oh, sorry, template. I didn't save it as a template. I saved it as lecture 6 structural engineering template. Okay, then you save all layers as reconciled. Saves the template with layers set as reconciled, which results in creating a layer baseline. This one saves the template with layers set unreconciled, which means a layer baseline is not created. Okay, we just leave it at that one, and then we say okay, and then we close it. Say yes. Okay, so I think that's the end of our lecture, and then I'll see you next time for our next video.